Hello, my name is Andrew Geary, and welcome to Seismic Sound-Off, in-depth conversations in applied geophysics. November's The Leading Edge presents a selection of studies that gives an idea of the breadth of geophysics that aids in mitigating natural hazards, covering natural and induced earthquake phenomena and landslides. In this episode, Heather Bedle and Chris Garneau explore public misperceptions of geohazards, the power of experiencing earthquakes, and ways to improve scientific communication with the public. Heather highlights a new tool that helps with one of the greatest seismic data limitations, and Chris breaks down the connection between people's concern about future seismicity and climate change. They also choose the most important areas to mitigate geohazards between geophysics, societal work, and education. This episode breaks down geohazards and their impact on the public and provides actionable steps for geoscientists to study geohazards better and discuss their work with others. Dr. Heather Bedle is an assistant professor at the University of Oklahoma in the School of Geosciences. Dr. Chris Garneau is an assistant professor at the University of Oklahoma in the Dodge Family College of Arts and Sciences, Department of Sociology. Now, let's get to my conversation with Heather and Chris. Well, Chris and Heather, I appreciate you joining me to talk about the November Leading Edge special section here. Not only is Heather, you helped with the special section in the introduction, but you also contributed to an article as well, pulling double duties there. So we'll start with you, Heather. Kind of a question about this special section topic in general. What are geohazards?
Well, I like to think about geohazards as a geologic event that can cause damage or create risks to humans and their property. And so oftentimes we tend to think of these as very large scale events that don't occur very often. Like you could think about like volcanoes or tsunamis, or maybe if you live in an earthquake prone zone, having earthquakes. But one thing that's important is that they can also occur on smaller scales. And these would be things that may just affect a local community or even part of a neighborhood. And as extreme weather becomes more common, we're seeing that some geohazard risks are occurring more frequently. Something along those lines would be landslides that are triggered by heavy rains.
Chris, let's throw to you now. Does the public have any common misperceptions of geohazards?
So this is kind of an interesting question. When I jumped into this, I just assumed that much of this was going to be political, but a lot of that has to do with the politicizing of natural phenomenon like climate change. However, in our analysis, I was pretty fascinated to find that politics really wasn't a driver in perceptions of seismicity specifically. However, if we investigated the belief that humans have a role in seismicity, which isn't what we were actually looking at, I think we would see a great deal of polarization. So there's a misperception there that comes from the filters that we have. In this case, the worldview that we bring to the table is really going to affect how we see this kind of stuff. So one obvious way of dealing with politicized science is to call for better science education, which I think it's good and it's a great start, but ultimately people are better at feeling than they are at thinking. I tell my students this all the time. I know you want to guide people to one way or another through logical thinking, and we're just not built like that as humans. We're built to feel first. So as long as people feel that human activity is either related or unrelated to geohazards, they're likely to dig into their position psychologically. So the exception here that we did find interesting in our analysis is that experiencing something firsthand that's very personal, that's very close to you, can be pretty powerful as a driver. So unfortunately, that's not the way that people come around to the idea that humans and human activity are inextricably linked to the natural world.
So Chris, let's kind of build off that idea. What even kind of prompted you to start exploring to include, this idea to include people's experiences and their perceptions and their attitudes to even study seismicity?
Part of it was the availability of data. So big data is just part of who we are. It's in our phones. It's everywhere. So you cannot get away from it. But the nice thing is that we've got more survey data that's coming out. And I'm seeing more and more of a convergence of survey data of people within the natural world, which makes sense. And I don't think we had done this until very recently. I used to talk to my classes and say, let's do some word association. So if I say, cold, what do you say? And they say snow and they say winter. If I say environment, let's do some word associations. They say green, they say trees, they say outside. What they don't say is humans. So there's something about our ecological understanding that is somewhat outside of the human experience. And what we're trying to do is kind of pull it in. So the first step is just that we've got data that's doing that is causing some of the convergences between the social world and human experiences and behavioral experiences and things that are happening naturally. So from my side, I'm really interested in how politics shapes our reality. So I'm a political sociologist. It's kind of the first thing I look at. That's my filter, how I see the world. Geohazards are real, tangible things. We can look at it and we can say an earthquake actually happened. Like we have measures for this. So what's fascinating to me is you can take two people and they can see that exact same thing. They can experience the same thing. They can feel the earthquake if it happens close enough to where they can both physically feel it, but they can come up with very different conclusions depending on how they've been psychologically primed to think about that event. So first, I think politics, but then I'm also thinking psychologically, how are people understanding these things? What's amazing is how we bring certain perceptions and bias into our basic cognitive thinking that changes how we understand natural phenomenon. So that's kind of how I got invested in it.
Yeah, I'll jump in. And this is kind of a broader personal experience. This project, and we have a few other projects that are similar, I trace them like all the way back to, I think it was a GSA Today article I read last year, sometime around the middle of 2021. And it prompted me to have a conversation with Chris because it was talking about disaster responses, I think, to one of the hurricanes. Before I moved to Oklahoma, I used to live in Houston and before that, New Orleans. So I was used to experiencing hurricanes and some of the extreme flooding and rainfall that we would get down there. And living there for the decade or so that I lived on the Gulf Coast, I was always very impressed with the community responses that I would see to these disasters, where people would really work together to try to get on their boats and grab people from rooftops or attics, or start pulling together extra supplies in their homes to give out to people who couldn't go back home. And so I had started wondering, like, okay, well, we see this outpouring of goodwill and helpfulness after a natural disaster, but how long does that last? Like, we have these feelings of goodwill and we'll help you out, but how long will we happen to help each other out? And so then once I moved to Oklahoma, and we have a lot of induced seismicity around here, and I began researching CCUS and geothermal methods for imaging the subsurface, those thoughts of how increasing seismicity may start affecting my community made me start thinking about, okay, well, how are people going to respond to changes for these climate mitigation techniques if natural disasters happen a little bit more often?
Yeah, it wasn't until reading this paper where I saw the connection you explicitly stated in there between carbon sequestration, carbon capture, and these induced seismicity events. So, Chris, you're talking about these real, tangible things that you can measure in earthquakes. What is important about a person experiencing an earthquake when they then start thinking about future earthquakes?
So this was a major driver in the analysis. We had a few different indicators in there. So it was kind of the perceptions of earthquakes happening. And then in general, like how many events did you experience? How many might you experience in the future? These kinds of ideas about just how do you perceive them in the real world. And that was so important to the analysis because in a lot of ways it dwarfed all the other things that typically as a sociologist I'll look at and say, well, this has to be some kind of a predictor. But really, experience had a lot to do with it. And we looked up one of the theories that kind of works with this. It's usually in other types of psychological literature dealing with climate change, but it's construal level theory, which is this idea that as you experience something and it has primacy to you, you're going to internalize it a lot more. So social psychologists often think about these really big events as a key source of cognitive bias. And this is just what humans do. So we use mental shortcuts all the time to reduce the amount of cognitive work that we have to do. And we do it so that we can save space for really important stuff like work, family life, whatever it happens to be. And we call these shortcuts heuristics. So in this case, we're looking at how humans use an availability heuristic. That's the actual name of the heuristic, the availability heuristic. So that's the tendency to point to information that comes to us easily and quickly. And so, for example, if it's rare that you see an airplane crash, but if you do, you're going to be a little more timid about booking a flight for the next couple of months. Or right when I moved to Oklahoma, very shortly after, there was a huge EF5 tornado that went through the town I was living in. I was okay, but I saw the destruction that was happening around me, and it really prompted me from then on. Every time I see a thunderstorm, I'm thinking EF5 tornadoes. Well, those things are very rare, and they also very rarely hit populated areas. So the availability heuristic is just, I can think of it. I know it happened. And the closer it happens to you, the more real that experience, the more easily it comes to mind. So overestimation of seismicity is likely to happen when people have experiences with earthquakes that they can quickly recall. Far more so than people who maybe have heard, oh yeah, I guess there was an earthquake on the other side of the state in Oklahoma. That information is going to go in and out of your brain very, very quickly. But when we're talking about things that you experience, that's going to be very easy for your brain to recall, which can then increase concern, it can increase fear, can have all kinds of impacts. So that personal experience is what we are heavily psychologically wired to understand. And in this analysis, that seemed to be a very important driver.
So even if you're thinking about future earthquakes and that can increase if you have experienced them, what is the connection, kind of the next step if you're, the next step between your concern about increasing future seismicity and your concern about climate change? Are those things connected?
So that was a weird one. There's actually, in the analysis, we find that there's concern for seismicity and concern for climate change are connected. So it seems unrelated scientifically speaking. But again, we're thinking about humans. So humans are messy. We're full of bias. We're full of illogical, irrational kinds of ideas. But construal theory that I mentioned before seems to work here in a spurious way. So experiencing drastic changes in the natural world gets lumped together in the minds of people. So all things natural just kind of gets lumped in together. But it kind of makes sense psychologically, because if you believe that human activity impacts climate change, then human activity can also create seismic activity or impact seismic activity. So this correlation maybe more of a statistical artifact measuring a psychological disposition to pay attention to the natural world. So really what it's doing is it's giving us that internal click that, I should really be paying attention. So it's not so much that people are connecting climate change with earthquake activity from a scientific standpoint. It's probably tapping into another construct that I'm interested in, which is terror threat management theory. And that looks at how we pay attention to threats and how fear is a huge cognitive driver for us. So both in terms of severe weather and seismic activity. So those two things don't have to be connected scientifically. We just have to be able to make a spurious connection in our minds to get us to the kind of that same conclusion. So that was a really kind of a fun and interesting finding from the paper.
Yeah, it just kind of builds off. I just can't help but think of Daniel Kahneman and Amos Tversky's work. Just putting heuristics even in the mainstream thinking is such a great thing. And it's nice to see it kind of focused in on the geoscience world. Heather, I want to kind of switch topics a little bit, but connected here. Let's start. I might mispronounce this here. What is aberrancy?
So I pronounce it as aberrancy. I'm not saying that I'm right, because sometimes I got a Southern accent. But aberrancy is a fairly new seismic attribute. So a way to look at reflection seismic data mathematically that can be used to help us identify subtle flexures of the seismic reflectors as we're trying to map them and analyze the patterns that we image. It was first used in 2014 as a horizon-based attribute by Dee and Gao. And then a few years after that, it was adapted for volumetric calculations by Key and Kurt Marfert. So now we can run the algorithms on a full 3D seismic volume. And we have it in our ASPE algorithms that my group uses. And what it is kind of technically is it's a derivative of the curvature, and the curvature is a derivative of coherency, which is an edge detector. So it helps us see where the curvature changes most rapidly, which curvature, for any seismic interpreters out there, know that we use curvature for seeing the curvedness of the reflectors, and we can link them to channels and channel facies and faults and fractures. And so it's a tool, a seismic attribute tool that can help us understand some of the subsurface faults and fractures where we have very subtle reflector offsets that might be below our seismic resolution of the data.
Why and how does including aberrancy in the seismic interpreters toolkit, how will that improve their work?
Well, you only want to use it if you have to use it. There's hundreds of seismic attributes out there that an interpreter can grab and look at, use for their seismic data. So one of the first things I always tell my students is know what you're trying to image, what you're trying to get out of the seismic data, and then pick your seismic attributes from that. So if aberrancy is one of the seismic attributes that you think will help you, look for faults and fractures. What I find particularly useful about it, and more of my students have been using it in their studies and research, is that it helps us with one of the greatest limitations that we have with seismic data, which is our seismic resolution. So we're often looking at mapping features that are kilometers beneath the Earth's surface. And we don't have the ability to see some of these geologic features in the same resolution as we would be able to if we were looking at, say, an exposed outcrop on the side of the interstate. But rather, seismic allows us to resolve features that are maybe on the tens to hundreds of meters scale, which means we're not even going to be able to detect small offset faults on the seismic scale, like if we're looking kilometers beneath the Earth's surface. And so these, down that deep may be areas where we're looking to understand a reservoir so that we could inject fluids for carbon capture and underground storage, or maybe geothermal purposes. And since we will be looking for small fractures and faults that are below the seismic resolution scale, aberrancy can kind of help us detect if some of those may be lurking down there. The reason we want to know if we have fractures or faults in the subsurface in these reservoirs that we may inject into is because they may allow the fluids that we're putting into the earth to move into other reservoirs where we may not want them.
Well, I love both of you are just cross-disciplinary activity in work here. So I'll be curious your perspective on this. If you had to put in order these three items, geophysics, societal work, and education, in terms of the most important in mitigating geohazards, how would you order them and why?
I'll jump in and go first. So I'll just defer to my own wheelhouse. And I'm going to say societal work, but that's not a strong opinion because I think we've got to be very multifaceted. And as you mentioned before, interdisciplinary, transdisciplinary, and how we approach most of these problems. So by societal work specifically, I mean to say that we need very, very good leadership, starting at the local level and local communities moving out nationally. So we really do have to have people who are willing to say, people who are very good at communicating, to be able to say very explicitly, these things are happening, human activity has an impact, and hey, this may have implications for industries in our states. I think science and education have more work to do. In other words, it makes it much harder to accomplish the same thing. But I do believe they can make a difference. We need better science literacy. That starts all the way back in elementary school, all the way through. And while human bias makes it hard for that education to be as impactful as we would like, we do owe it to our communities to have well-informed people. It's the bottom line. And in the meantime, people are working within geophysics. They're on the front line of solving a lot of the problems that the public is either uninterested in addressing or don't have the adequate knowledge base to really tackle head on. So it really does have to be multifaceted. So that's the order I would put it in.
I'll jump in and do my order next. So I would say education is definitely first for me. I'm not going to repeat a lot of what Chris just mentioned, but some of the things we really need to do better is to educate individuals about the hazards and the risks that exist in their communities. Not only that they exist, but how the individuals may be able to mitigate those risks, or the communities can mitigate them, and maybe how to adapt or lessen some of these geohazard risks. But So individuals don't always have the means or resources or even awareness of the risks and how to respond to them or the ability to respond to them. So I put societal work as my number two, because you need the larger society, the local community, the regional community to also help provide solutions to the geohazards and ways to mitigate them. And so, I'm kind of imagining, I can't see Chris's face right now, but I'm guessing that he's smiling when I say, it's education and then social work and geophysics last.
Yeah. Just pump the air. There you go.
Well, there's three articles in the special section for this month, and this is to both of you, and you can take either side of this. What is one new takeaway on geohazards you had from the special section, or is there a developing topic that you're particularly kind of paying attention to or excited about within geohazards that you're following?
Yeah, I'll go ahead and start. I think in terms of where we're going to go from here, we got to talk policy. And this is the hard part for social scientists. We are very, very good at detecting problems. We are not terribly good at offering solutions. So that's part of the public policy. I think we need to get people who are involved in public policy in on the conversation as much as we can. So we do need a way to get knowledge from experts in these fields to the public in a way that's seen as legitimate. So that's the important part. I mean, we can think about the pandemic or really anything that deals with large scale public messaging. It's all about how that information hits, more so than the information that's given. So it has to be the right kind of appeal. As I mentioned before, people are feelers and not thinkers. We want to feel right about something. So we have to have the right kind of messaging. I think it would be incredibly impactful to have experts seek out those who have experienced geohazards and relay their personal stories. I think that would be far more powerful than any public information campaign or just plain facts that we spit out. The emotional impact of other people working in concert with good scientific information can go a long way.
Yeah, I'll jump in and kind of answer this from my takeaway. So I've spent most of my career, 20 years or so, just staring deep into the earth and not worrying about the people side of anything, just what's down there. How can seismic waves help me see it? What does this tell me about past environments or fluids? But so working on this special section with Sebastian Ullman, who is a co-assistant editor with me, he studies landslides. And so kind of talking and communicating with Sebastian about his landslide work and then working with Chris on the study we did with seismicity, it really opened my eyes to the gap that exists between societies and geophysics, or even like the local societies and geology. Like we're not always in tune with what we're doing and thinking as natural scientists to what the social scientists are doing. And so I've realized that, kind of like what Chris said, there is much more work that we need to do to communicate what's happening between our two sides, because the Earth, it's not a static place to live. Even though oftentimes we see these geologic processes as extremely slow, they still have the ability to affect us, individually and in larger groups.
Yeah, I interviewed someone a while back who, due to the advancements of technology, they can now measure the actual mass of rocks are changing with the moon. You just think this like a static rock, that's a rock, but it's really, it's a very dynamic system that you all are studying, and people are certainly no different in that regard as well. Kind of closing here, and we'll start with Heather on this one. What principal teaching or point of view has helped you succeed in your field?
Okay. Well, I'm going to say kind of appreciating the diversity of minds and methods. So during my time with Chevron, I worked with a very international community, international researchers. And now that I'm professing, I have a student group that comes from, all over the globe, and they have different educational backgrounds and cultural backgrounds. And so starting to work across different disciplines and merge the natural sciences and the social sciences, I'm realizing that all of our different experiences that we have in our cultures give us a very unique perspective on problems. And so while I may think that I have a solution, it doesn't mean that my solution is right, or it can't be kind of aided and helped with other people's ideas and solutions. So I think I've kind of begun to hit my stride more as a researcher as I'm open to hearing what other people think and how they've analyzed a problem and how their experiences have changed things.
Yeah, I'm gonna answer that question in a similar way. I think Heather and I are similar in the sense that we both stay curious. That's kind of my thing is I'm open, I stay curious. I want to know the next thing that's happening. I was trained as a sociologist. That's what my PhD is in. But I was lucky enough over the course of my career to teach classes with math departments, mostly statistics, but also to teach psychology courses, to teach classes in political science, even a music course once before at the college level. So I get really curious about things. I never actually took a single psychology class through my undergraduate or graduate years. Yet this is what I'm doing right now. I'm trying to figure out how sociology and psychology and even politics and economics all converge, and now bringing in the natural sciences. Even though I was never very good, to be quite honest, I'll go ahead and divulge this. I was never good at earth science or chemistry or really anything else. So, but the more I branch out, the more I realize it's all interconnected. My thought as I move into my academic career is to not dig in as much as I can, meaning I know there's a proclivity to become a specialist within a subfield of a subspecialty of one specific branch of scientific inquiry. And I refuse to do it. I just want to see what else is out there. I think there's people that do that. I think that's very good work. I'm glad they're doing it. I'm going to be one of the people that's going to be jumping around disciplines because I think it's so much fun.
Well, that's a great place to leave it. I appreciate this conversation, kind of a wide-ranging, touching on some topics we don't always get to talk to in this podcast. So that is very exciting. So Heather and Chris, thanks for joining in today.
Oh, no problem at all. It was my pleasure.
Yeah, appreciate being here.
SEG produces Seismic Sound Off to benefit its members, the scientific community, and inform the public on the value of geophysics. To show your support for this show, please leave a 5-star review on Apple Podcasts and Spotify. Simply go to Seismic Sound Off on Apple Podcasts and Spotify on your phone. It takes less than 5 seconds to leave a 5-star rating and is the #1 action you can take to show your appreciation for this free resource. And follow the podcast while you are on the app to be notified when each new episode releases. Original music created by Zach Bridges. This episode was hosted, edited, and produced by me, Andrew Geary at 51 Features. The SEG podcast team is Jennifer Cobb, Kathy Gamble, and Allie McGinnis. Thank you for listening. This is Seismic Sound Off, signaling off.